Hello and welcome to our practice of subtraction with renaming today. So we want to find the difference of this mixed fraction here. Okay, so we have 11 and 1/9 minus 3 and 2/3. Now typically when we're working on these, we're just going to take away, so we would typically do 11 minus 3, which is simple, and then we would do the difference of the fractions, which we've practiced in the past. But first we need to make sure we don't need to borrow. Okay, so we need to get these fractions in terms of comparing like with like. Okay, so when we have 1/9 and 2/3, we need to get this into a common fraction, which I know we've practiced in the past. You remember typically the pattern is going to be to find the lowest common or least common multiple of 9 and 3. So if you remember when we used to do that, so if we did multiples of 9, we'll just do over here, 9, 18. So those are multiples of 9. How about multiples of 3? And again, we're doing it because of this 3 in the denominator over here, right? We're looking at the denominators. So 9 and 3. What about multiples of 3? Okay, so where does the match occur? It's when we do 9 times 1, and that matches when we do 3. Okay, how did we do this? We did 3 times 1 is 3, 3 times 2 is 6, 3 times 3 makes 9, and that is the common denominator now. So how do we go from 3 to 9? Well, we multiply by 3. Okay, so I need to multiply this bottom by 3. Whatever I do to the bottom, I have to do to the top. Okay, so 2 times 3 is 6. I'm going to start writing this up here so I have room. 3 times 3, the denominator would be 9. Okay, so I'm going to rewrite the whole fraction now. Okay, so this was now 3 and 6/9. Okay, so the fraction 6/9 is the same exact number as 2/3, but we just had to turn it into a denominator of 9 so that we could perform this operation over here. Okay, so we now have 3 and 6/9. Over here we have 11 and 1/9. Okay, now here's the trick. If we have 1/9, would we be able to take away 6/9? Well, not quite, because if we have a number of slice of pizza that has 9 possible slices and there's only 1 slice, would we be able to take away 6 slices? Not without opening up some whole boxes that haven't been touched. So that's exactly what we're going to do, is we're basically going to borrow from this whole number over here so that this fraction has something to take away, to be taken away from. Okay, so another way to think about this is 11 plus 1/9. So what if we took away 1? So if we took away 1 from 11, that would of course be 10. Now it didn't disappear. We now have basically a pizza box that has now been opened. Okay, so we used to have 11 pizza boxes that were unopened, and then 1 pizza box that only had 1 of its 9 slices remaining. So what do we have now? Now we have 10 pizza boxes that haven't been touched at all. We also have a pizza box that's been just newly opened with 9 of its 9 slices in there. And we have this 1/9, this cold pizza that we had before. Okay, now I'm just going to rewrite the rest of this so we don't confuse ourselves. Okay, so just so you don't know that that disappeared. So I'm going to cover it up for a second, but I just wanted to write it down so you didn't think it disappeared or anything like that. So what we need to do now is we need to put these fractions together before we perform the subtraction. Okay, so when we can add fractions if they have the same denominator, check. So all we do then is we write that denominator, because they're the same, the denominator does not change, the numerator, the top does. 9 plus 1 is 10. Okay, so 9 plus 1 makes that 10. We drop down this whole, remember this is our stack of pizza boxes that's unopened. But now we can perform the operation. Okay, so what we're going to do is we have, let's look at the whole number. So what is 10 minus 3? 10 minus 3 would be 7, right? 10 minus 3 is 7. And these are the whole numbers. Okay, so maybe we ended up having a certain number of pizza boxes and we wanted to give away 3 whole boxes and 6/9 of a pizza box to our friend, or maybe we're distributing them to different classrooms. So after giving these away, we're going to have a total of 10 minus 3 pizza boxes, but we're not done. We also have to work on the fraction. Okay, so what is 10/9 minus 6/9? Notice now that after borrowing from the stack of warm pizzas, now we have a numerator that has enough to be taken away from. Where before at the very beginning, if we started with even though the denominator was the same, so we could do the math, 1 take away 6. Okay, there's just simply not enough pizzas to give away. So 1 minus 6 would give us a negative number. That's why we had to do all this borrowing. Okay, so 10 minus 6 would be 4. And remember, when we do the operation with fractions, we just check to make sure that the denominator is the same. They're both 9, but we don't change it. Okay, so the result is going to be 7 and 4/9. Just like that. All right, so that's a lot of explanation. Let's see if we can go a little bit faster through the next one. So remember, we want to think of this as subtracting whole numbers. Right, so we could do 6 minus 3. But do we have a fraction here? Here we don't. 6 and what? Really, it's like 6 and 0 halves. Can you take away 1 from 0? We can't. So what do we have to do here? We have to borrow one of the whole pizzas. So this 6 could be rewritten as 5 warm pizzas. Okay, and these pizzas are going to be split into 2. Maybe they're more like personal pizzas instead of a giant pizza, right? So we want it to match the fraction over here. So when we open, we take one of those 6 hot pizzas. Now we only have 5 that are left completely unopened. And because we took one off the top, now we have a pizza that still has 2 of its 2 slices. However, now we can perform the operation. Okay, so let's rewrite this other side. 3 and 1/2. So 5 take away 3 is 2. That wasn't too bad. Now we want to see if we can do the fraction side of this. So 2/2 take away 1/2. Remember, we check to ensure that the denominator, the bottom number, is the same. That's going to stay the same. The only thing that changes is the numerator. Remember, now forget about the 5 and the 3. We're just looking at subtracting the fraction. Okay, so 2/2 take away 1/2 leaves 1/2, right? 2 minus 1 leaves 1. So the final answer then, after we borrow from the stack of warm pizzas, the whole number, we perform the subtraction on the whole numbers. 5 minus 3 makes 2. And then when we do the operation on the fractions, 2 minus 2 over 2 minus 1 over 2 gives us 1/2. Okay, so we're looking at 2 and 1/2 is how we would say that. Okay. Next one. Remember, the first step is always to get the fractions in like terms, so to speak. So if this has a denominator of 8 and this has a denominator of 2, I'm going to look at the smaller denominator. How would I get from 2 to 8 using multiplication? And of course, would it be 2 times 2? No, 2 times 3. 2 times 4 makes 8. So 2 times 4 makes 8. Whatever I multiply on the bottom, I have to do on the top. So don't even think about doing math again. It's not 1 times what? No. Do 2 times what to get 8. 2 times 4 to get 8. We do that both on the bottom and the top. Okay. So let's see what these fractions look like now. So this is going to be 4. Didn't touch that yet. So 4 and 3 over 8 minus 3, and 1 times 4 is 4, over 2 times 4 is 8. Okay. Don't look at the whole numbers yet. That's going to work out. So we have 4 take away 3, but we need to make sure that the fractions work out as well. So 3/8 take away 4/8. Okay, so if we simplify this a little bit, the denominators now match, which is good. Can we do 3 minus 4? No, we'd that 3 over here minus 4, we'd get a negative number. Can't do that. So we need to borrow. Okay, so we open one of the warm pizza boxes. We have now 3 warm pizza boxes we didn't touch. We also have, okay, so we just opened that pizza boxes, and how many slices are in the box? 8. So we just opened the box. We didn't take any yet. This is from the warm stack of pizzas we just took from, okay? So we have now a fresh box that we just opened, and we have the cold box of 3 over 8 minus, and we didn't touch this. I'm just going to bring it down. We didn't touch it. We didn't change it. Just don't want to forget about it. Okay, so we have to do a little bit of work here, okay, on the side that is being taken from. We need to put these fractions together. So 8/8 and 3/8 would make 11/8. Okay. So we do the 3 minus 3 again. So how many warm boxes? We actually gave away all 3 of our warm boxes. So we're going to have 0 and 11/8 and 4/8. They have a common denominator. So it's going to be a denominator of 8. And what is 11 minus 4? That would be 7. So we don't typically say 0 and 7/8. We would simply write 7/8. That would be our answer. Okay, let's do this next one quickly. Now this is a little bit tricky because we would typically look at the denominator of the fraction that we're working with and see how we'd multiply to get 8. 6 times what makes 8? That is just not going to work very well. So we're actually going to have to change both of these fractions, okay? So let's look at multiples of 6. Maybe we'll even do that back over here, okay. So 1 times 6 makes 6. 2 times 6 makes 12. 3 times 6 makes 18. 4 times, we're just looking at the multiples of 6 here. 5 times 6 makes 30. 6 times 6 makes 36. 7 times 6 makes 4. So let's see how we're doing here. So this is our 6's multiples, and we're going to see if we can find the least common multiple of 6 and 8. You've probably found it already. I just wanted to show you how you can make the table if you ever get lost. Okay, so now we're going to do 8's. So 1 times 8 is 8. 2 times 8, 16. Okay. So the least common multiple of 6 and 8 is 48. Okay, so the denominator that is going to be common of these fractions is 48. So I know it sounds a bit daunting, but it's really not that bad. The other way that will always work with these, if you don't want to figure out what the lowest common multiple would be, is to multiply each of these denominators by the other denominator. Okay, so I'm going to do 8 times this side. Okay, so 8 times 6 would be 48. That's our denominator. What is 8 times 1? 8. Okay. So we have 9 and 8/48 minus 3, and now we're going to do the same thing. So 6 times 8, 48. 6 times 5 is 30. All right. So see how that works? So we just did this 8 times top and bottom over here. And we did the 6 times top and bottom over here. And we got a common denominator to work with. Now, can we do 8 minus 30? We cannot, because we go negative. So we need to borrow from one of our hot pizzas over here. So instead of 9, we're going to have 8 hot pizzas. Okay, and then a fresh pizza that we just opened that has all of its 48 slices. Then we have the cold box of this 8/48 minus, I'm just going to copy this down. I didn't change this yet. Before we do the subtraction, we need to put this side together. Okay, so we need to put those fractions together. Common denominator, so we just add the numerator. So that's going to be 48 and 8 makes 56 over 48. Drop down our warm pizzas over here. Okay, now let's subtract the hot pizzas that are still in the box. They're whole. So 8 minus 3 would be 5. So we have 5 hot pizzas left. Now let's do the fraction. 56 over 48 and 30 over 48. Common denominator. What is 56 minus 30? That's going to be 26. Okay, so what we're looking at, we should be done. Do we see a 5 and 26 over 48 in the answer choices? Not quite. Now this is a little bit tricky. It's going to take practice. We need to simplify that fraction. Anytime both the numerator and denominator are even, for example, we know that they are at least divisible by 2. Okay, so what is 26 divided by 2? Would be 13. 48 divided by 2 would be 24. Can we keep going? No, odd and even, so we know that's probably as simple as we can get that one. Okay, so 5 and 13/24, so actually this answer here That's your final answer, okay, after you reduce that fraction. That was a long one today, but great job. Bye-bye.